calculus, differentiation, finding the derivative. So the question says, find the following derivative. They actually said dy dx, this thing. But they didn't say dy dx, they said dy dt, because of this y in terms of t. It's technical. I keep talking about the notation, you're going to lose a mark, but it won't be a mark at every sum. The notation mark will be 1 mark somewhere. So please don't go into such a stress about notation. Okay. So first things first, can I immediately start deriving? No, because that t must be at the top. And if I take it to the top, it's going to be 2t to the negative 2. Are you with me? Not one of these sums had one like that. But if it was, for instance, 1 over 2x, let's make another example in between here. And I wanted to derive that thing. You'd have to write y is equal to
2x x minus 1 over 2.
You're right, it is x minus 1 over 2. Because there's not one of them works like that. If there's a half there, this is actually already the coefficient. It's only the x that's where it's not supposed to be. Take it to the top, but then I would like you to write it separately so that you're ready to say exponent times coefficient. So this is better to write it this way than writing x to the negative 1 over 2, because then you're seeing it separate. Exponent times coefficient. Would you please remember that? So the derivative of that would then be dy dx is equal to negative a half x to the
negative 2.
Okay, the only reason I wanted to show you that because you were all wondering what now. The 2 has got nothing to do with the x. It doesn't also come to the top and become, I don't know what, negative 2. It's not right. So that is a half x to the negative 1. Are you with me there?
Yeah.
Anywhere that it happens, that's what you'll do. I'll erase just now. Now that it isn't the correct form, I can dy d. T, please, if you write dy dx here, you're going to miss them all. And then you're going to derive by saying exponent times coefficient is 8. Take away 1 is 1. Exponent, which is 1, times the negative 9 is negative 9. And t to the 0, which falls away because it's negative 9 times 1 then. This one will be negative 4 t to the negative 3. Which we can write on various ways, please don't. Leave it like that. Don't simplify and make mistakes. Next one. Is it derivable? No. You've got to write it as u to the power 3 over 2, not 2 over 3. And is this thing derived now? No. So it should still state the derivative of this thing in the bracket is the derivative of this thing in the bracket. Take note. du. How come du? Because everything in the bracket is in terms of u. Okay, if it was x's in here, it would have been dx. T's in here, it would have been dt. I'm deriving in terms of u. And then if I do the derivative, it's going to become 3 over 2 u to the half. And that's it. What comes here? Just the equal sign. Read it. The derivative of the bracket is the derivative of the bracket is answer. The derivative is. Happy on that?
Yeah.
Okay, for the next one they say find me dy dx. They are absolutely right, but it is y in terms of x. Some things to do before I can get to the derivative. This is fine. Please don't start deriving half of the sum in between and saying, well, I can do this one so long, but I can't do that one yet. You've got to do them all together, otherwise notation's wrong. This will be minus 8x to the half and plus 3 to the x to the
Negative
negative 1. Can I derive now?
Yes.
So it's dy
Over dx.
dx. Okay? Answer? 21x
squared minus 4x negative a half
negative a half.
minus 3x negative 2.
Happy? Okay. dy dx again. What's wrong?
Y and X on the same side.
You have to have y equal to whatever in terms of x to do derivative of y in terms of x. You cannot do that unless this is just equal to y. So how do I get it away? Divided by. And then we know that shouldn't stay like that. We should write it as x to the negative 3. Then we can do dy dx. So this is crucial. If this says dy dt and it wasn't y alone in terms of t, you had to make it right first before you can derive in terms of t. I had to get the y alone first, now I can derive in terms of x, which will give me
Minus 9x negative 4.
okay, you got it. Exponent times coefficient minus 1 from the exponent. The question says, do this. So it's big letter D, differentiate what?
The f of x, that thing.
But there's the f of x, so they're just combining the stuff now. You should be putting that in here now. But that has to be simplified. So let's rather simplify it out there. Can you put it in here and start simplifying? It's up to you. If we want to simplify before we come here, and then we can differentiate immediately, that'll be good. So let's see. What do you have to do?
Foil.
Foil, because you have to have separate
Dames en
terms.
heren, jammer voor de vergeten kan u hoor of asseblief naar juffrouw Kuylen se klas toe gaan. En A10, dankie.
Okay, so I'm saying 1 times 1 is 1, times with 1 stays the same, times with 1 stays the same, minus times a minus is a plus, 2, x to the half times x to the minus half
0,
is x to the 0.
which is
Bring it fella away. Can we add a little bit in between here? Nope.
no,
This is not like terms.
yeah,
Can't do anything. So this would mean that this is dx of 1. Oopsie, I can add that. Can I write the 3 here now? Will they be happy with me on that? Writing it there, negative x to the half. That's why you said yes, there is a common factor. It's like terms. Now we can derive. Let's read it again. It says the derivative of what's in this bracket is equal to answer. Are you with me here? The derivative of this bracket is, you shouldn't have a d here anymore. You shouldn't have d equals there because they're going to deduct a mark from you. It says the derivative of the bracket is, let's do it, 0. And if you're thinking you want to write 0, do it. Then this one would be
minus
negative half x to the
negative
negative
half
half
minus
plus
plus
1. And if you want to write the 1 also, and if
yes.
you want to write minus 1.5, I'm happy with that. I like minus 3 over 2 better, but there's nothing wrong with it. Take away 1 is minus 1.5 or minus 3 over 2. And then you're done. Don't manipulate, don't do anything else. Last sum says, do 2 of them. Because you start here, this says do the derivative of y, which is that. So I'm going to put it here. And once I've done it, I do it again.
Okay.
Are you with me here? So before we get it in here, let's simplify because I'm seeing stuff to do. First, you'll have to do the bracket squared. So let's write it out. And say that bracket squared will then be x to the 4 plus 2x squared and plus 2x squared is going to be plus 4x squared and plus 4. Then everything is over x squared. What are you going to do with that over x squared? Can you take it to the top and make it x to the negative 2? You can, but then you've got to keep this thing in a bracket and time it in. Another option is it put each one over their own denominator. Guys, if you know about all this stuff, you can actually use it. If you don't know about it, you've got a problem. Have I simplified it?
No.
Okay. Each one over their own denominator, so this will become x squared plus 4. This is simplified, but I'd like it to be derivable. So 4 x to the negative 2. You're not always going to write negative exponents now, only when derived. So now I can come back here and say, okay, so this will be dx of the dx of x squared plus 4 plus 4x negative 2. So let's do it bit by bit. So we start off here. This derivative will be equal to 2x,
Minus 8x.
and then that's plus 0, right?
Yes.
If you want to write the 0, go for it. And this will be minus 8,
X.
x to the negative 3, but you haven't done this last bit yet, you've got to do it again. Only because they said so. Double derivative gives you what? Acceleration. But nothing to do with this sum, just for future reference. Do the derivative. 2. You're not going to do 0 again. 0, 0. And then this would be plus 24.
X. Now minus 4.
And that's it. So in your exam, expect one of the first questions to be these derivatives, either 1 or 2 of them, normally 2, and in total they're about 6, 7 marks worth. These shortcut derivatives, because what we're going to do next is the long way derivative, which we're going to be doing with a formula, which we'll do next time.